Sevens, I hope you guys had a wonderful long weekend. Hopefully you got to enjoy, well, the one day of nice weather we had, but hopefully you're going to be able to enjoy some of the nice weather we're going to have this week. With that, we're going to jump into our Wednesday math. We're almost done with this unit. It should be Wednesday and Friday, and then Friday is our last section of this unit, and then we're going to move on to our other unit. So for now, we're going to do our review using that formula or those steps that we talked about in our last lesson. And then we're going to talk about external angles. So we've been doing internal angles this far. We're going to talk about external angles. So if we have a 11-sided polygon, how can we figure out how many triangles fit into it? The rule is you take the number of sides and you minus and you subtract 2 from it. So I do 11 minus 2 gives me 9. So the number of triangles that will fit inside this polygon will be 9. If I take 9 and I multiply it by 180, because the internal angles of a triangle always add up to 180. So if I have 9 triangles inside of this shape, that means the internal angle will be whatever 9 times 180 is. So 9 times 180 gives me 1620 or 1620. So the total internal angles of this shape is 1620 degrees. So if I had an 11-sided shape that was a regular sides, as in all sides were the same length, all the angles would add up to 1620. However, what would each internal angle be? That's what we're going to find out. So I have to take 1620 and then I divide it by the number of angles that are going to be inside this polygon. However, the number of angles is the same as the number of sides. So if there's 11 sides, that means there's 11 internal angles. Okay, so think about a triangle. 3 sides to a triangle, 3 angles. And that's our rule with polygons and regular polygons, is the number of internal angles is the same as the number of sides. So I take 1620 and I divide it by 11, and this will give me each individual angle. So 1620 divided by 11 gives me 100, and it's going to be a decimal number, is 147.27 degrees. So that means each individual angle is 147.27 degrees. So if I took 147.27 and I times it by the number of angles, that would equal the total, which is 1620. All right, so that's our 11-sided polygon. Our 15-sided polygon is the same process, however, we're just dealing with different numbers. So I take 15 to get the number of triangles. I subtract 2. Okay, so you're always subtracting 2 to get the number of triangles. So I take the number of sides, subtract 2, and this gives me 13 triangles. 13 triangles were going to fit inside this polygon. And that's the least number of triangles I can do. I take my 13 and I multiply it by 180. And this gives me 2,340 degrees. So if I have a 15-sided regular polygon, as in every side is the exact same length, the sum of all the angles would be 2,340 degrees. To figure out each individual angle, I take that 2,340 and I divide it by the number of angles, which is the same as the number of sides. So in this case, it's 15. So 2,340 divided by 15 gives me 156 degrees. So each angle would be 156 degrees. So if I have a 15-sided shape that is all pretend that's 15 sides, each angle would be 156 degrees. And that only works for regular polygons. So this only works if every side of that polygon has the same length. So it means if one side's 2 centimeters, they all have to be 2 centimeters. All right, and that's our review. So today we're going to talk about external angles. We're going to talk about different types of external angles. They are pretty much very similar between triangles and other polygons. We're just going to talk about triangles and regular polygons today. It's really quite simple. When you're dealing with external angles, if you're given a shape like a square, let's say, if I give you a shape like a square, we know these are the internal angles. The external angles are done by taking this line, the lines that create, or the sides that create the shape, and extending the line. So I have 1, 2, 3, 4. You're only going to have the same amount of external angles as you do internal. So if it's a 4-sided shape, there's 4 internal angles. That means there's 4 external angles. I can't do angles like this. I can't extend the lines both ways because it will not work. And then all of a sudden you have 1, 2, 3 angles right there instead of just the one that you need. So when we are taking a shape, so let's say we are going to do, I'll show you how I did the triangle. When you're taking a shape, you have your lines, just choose a line, you extend it. 1, then you go to the next line, 2, and 3. It looks almost like a weird pinwheel in a way, and that's kind of what you're aiming for. If you have 2 lines coming out of the same place like this, it doesn't work. So you only have to just extend it a little bit. The shapes you're going to be given today should already have the lines extended for you. So you don't have to worry so much about that. It's just recognizing what it looks like. Now, to find the external angles of a shape, you guys remember supplementary angles when you have a straight angle and then there's a line coming out, and let's say this is 48 degrees. Your mission is to figure out what this angle is, and it has to add up to 180. That's the same thing with external angles. So with this triangle here, I have a line jutting out the bottom like this. If I know these external angles of this triangle, so let's say this is 25 degrees, this is 45, no, it's not, that's too small. We're gonna make this like 88, and whatever that other angle is, so 180 minus 25 minus 88 equals 67 degrees. So this one here is 67. So all 3 angles add up to 180, right? So this equals 180 degrees. External angles. If I take this angle right here with my extended line, it looks like our supplementary angle. Because if I erase this part here, if I white it out and hide it from you, it looks like a regular supplementary angle. So if this is gone, that just looks like a supplementary angle that we've already been dealing with. And this is how external angles are treated. So if I'm trying to find the external angle right here, basically I take my 180, because remember our supplementary angles always add up to 180. I take 180 minus 25. This gives me 155. So that means this angle right here is 155 degrees, because this, I created a straight line that's 180 degrees, and I made a supplementary angle, essentially. See, it all comes back. They're all related to one another. And this would be the same operation if I extend this line and I'm finding this angle right here, and if I find this angle right here. And there you go. So that's how we're going to do it. So I'm going to draw another triangle because we're going to practice one more triangle, and then we're going to go on to regular polygons, which is very much the same process. The only difference is with regular polygons, they're a little bit nicer to deal with because instead of having to find the angle of each corner or of each side, you only have to find one. And I'll show you what I mean by that afterwards. So here, let's take a triangle here. We have 90 degrees here. So this is a right angle triangle. 90, let's do 35. So that's 35 degrees, and our last angle is 180. Actually, yes, we're going to find out our last angle, which is 180 minus 90 minus 35 equals 55. So our missing angle is 55 degrees. Now we need to find the external angles of this triangle. So here, here, and here. So notice I only have 3. In this case, it doesn't look like a pinwheel. Sometimes triangles will not. Usually regular polygons will. This is just for my demonstrating, but we only have 1, 2, 3 lines coming out that are supplements of other angles. So what I mean by supplements is there's that straight line continuing and we have this known angle. We have to find this missing angle. How do we find the missing angle? Supplementary angles has to add up straight line equals 180 degrees. So if I have a line jutting through it, that means this plus something must equal 180. So if I know that this here is 55 degrees, I take 180 minus 55. This gives me 125. So my missing angle is 125 degrees right here. And those are supplementary angles. This one right here is 90 degrees. If this is a straight angle and it adds up, so if I have a straight angle and one of them is 90 degrees, what must the other one be? Must be 90 degrees, because 90 and 90 make 180. So right off the bat, this is another right angle, and this is 90 degrees as well, because 90 and 90 equal 180. Now we have 35 degrees. Same process as before, I take 180 to find this supplement, minus 35 equals 145. 145 and 35 make 180. And those are my external angles of the triangle. All right, I'm going to quickly do polygons. Polygons are even simpler. Triangles, we had to find all 3 angles. For a polygon, we don't need to do that. Here's the steps for polygon. If the internal angles are already given to you, the hard work is done. However, in this case, we have a hexagon. I didn't give you the internal angles, and I did that for a reason. Because I'm going to do my steps. So I have 6 sides. To find out the number of triangles, I minus 2, which gives me 4 triangles. I take my 4 and I multiply it by 180 because each triangle adds up to 180. 4 times 180 gives me 720 degrees. Each angle is 720 divided by 6 because there's 6 angles. Each angle is 120 degrees. So right here, this is 120 degrees, as are all the other angles, are all 120. What do we do to find the external angle? Well, it's a straight line. We are trying to find the supplement. So if I have 120, I'm just trying to find this missing angle right here. How do I do that? I take 180 minus 120. This gives me 60 degrees. If it is a regular polygon, as in every side is the same length, every external angle will be the same amount. So each external angle in this case is 60 degrees. And that's how you do it. Okay, so what you're gonna have today is you're gonna have a bunch of regular polygons. You're gonna apply those same steps that we were doing on Friday to those shapes. So you take the number of sides minus 2, then you take that number, times it by 180, take that number divided by the number of angles. So what we were doing on Friday, same thing. Now all you're doing is just finding whatever the external angle is for those shapes. So the lines are already going to be given to you. All you're really doing is just finding out what that external angle is. So if it's a hexagon, it's 60 degrees. If it's an octagon, it might be 40 degrees. I don't know off the top of my head, but don't take that as your full answer. But that's essentially what you're going to be doing today. And then you're going to be having triangles, and you're also going to be doing the same thing with triangles, except for triangles, each angle will be different, as you can see here, like 90, 125, 145. These are all going to be different angles. And that's it. So otherwise, I will see you guys on Friday. This is our last, Friday is going to be our last lesson of this unit before we move on to the next one. You guys have been doing fantastic. You guys all got emails this past weekend where it has all the marks I've managed to accumulate. If there's a missing one here or there, I've noticed that sometimes I just forgot to type them into my Excel spreadsheet that I used. If there's a missing mark and you absolutely handed it in and I should have it, just let me know and I will quickly give you that mark and update it. Just because it was just a crazy marking weekend for me. So I might have missed a couple things here or there. Let me know if that's the case. But otherwise, you should be getting, I'm going to start doing my marks regularly. So instead of doing mass marking like this, I'm going to try to do them. Usually I try to wait until about a day after that lesson closes to start marking, just because I want to make sure if there's any people who handed in things late, that they have that chance that they're not kind of cut off from handing it in. So otherwise, that's it, and I will see you guys on Friday. Let me know if you have any questions.